Hi, I'm Tony Gonyon from HP Tuners. I'm the sales manager for Ford Gas North America. Today we're going to talk about Ford tuning tips and tricks. Things we're going to need for this is a laptop connected to the internet. We'll actually need the software downloaded. We'll also need MPVI2. I recommend the extension cable as well as the cable that comes with the device. For the software, we recommend using the beta software for any of your late models because it's the most up-to-date. It's updated 2 to 3 times a day, and when you're doing late model product, you want to make sure that you have the correct software for it. All right, let's get started. Today we're going to use a Ford GT350. Other than the Ford GT, this is the flagship of the Ford road racing department. It's got the Voodoo engine turning 8,300 RPM, flat plane crank, and today we're going to do some tuning on it. Let's get started. Let's get ourselves hooked up. Get our laptop here, get it set up on here. My handy dandy little screen that a friend of mine made years ago for me to be in my office. Obviously you want to be comfortable in your office, so here I am with my own little device here. Make sure we're plugged in, ignition switch is on. The first thing I want to tell you to do, scan the vehicle. You always want to check, scan the vehicle, make sure we're not getting something that's not messed up originally. So I'm going to connect to the vehicle right off the bat just to see if I have any DT menus. There is another way to do this, by the way, so you know. The info log, if you click on your info log and save the info log at the very bottom of your info log, it will show you any codes that are up as well. So a little tip information there for you. And you can always save that. In this case, we're going to hit the check engine light here to see what we got. Any DTCs. And we have no DTs detected, which is good. All right, so we're starting off fresh. We're good to go. So I'm going to exit out of that. I'm going to go ahead and stop the scanner at that point, and we are going to start off going into the software. All right, so now we're going to go ahead and select the read vehicle. You can use Control R as well. Gather info. When you hit gather info, what it's going to tell you is the VIN. It's also going to be the type of controller that you're using and the strategy of the vehicle, which is actually the tear tag that goes with the computer for Ford calibration. As you can see, it's a 2018 Ford Mustang Shelby Coupe 5.2 liter V8, and it's a Voodoo engine. So TC 1791 ECM. We would actually hit the read button here. It's going to go actually read the PCM. You'll notice when you do this that you're going to see things turn off. You'll see lights turn off. You'll see things turn off, and that's the system actually taking and saving battery power so you can actually read it without messing up the computer. Good. Remaining time about 3 minutes. During that 3 minutes, we can entertain and tell you all about kind of neat stuff with this. So one of the little acronyms I use when we're tuning cars is called FASTT, and that's fast with 2 T's. Fuel, air, spark, torque management, and transmission. Even if you have a manual transmission, there are things you will need to change in the tune to help with the car and the torque management and drivability, as well as certain gear ratios if you change transmissions. So I always remember FASTT with 2 T's. All right, so we're about a minute away on the read. One of the things you'll know on the later model Fords 18 up, sometimes it'll take over 20 minutes to read the vehicle. And the reason it takes 20 minutes is because the process is so large and you have to read the engine and the transmission. So don't be alarmed when it says 20 minutes. This vehicle being an 18 GT350 was only 3 minutes for the read because of the processor. Okay, we just read the file, and now we're actually going to save the file. So I'm actually going to go into my documents and my HP tuners and put the file here for now. Logs and tunes, Coyote. I'm going to call this GT350. When you save a file, you can save it any way you want it. As long as you remember how it's saved and you follow that standardization, it'll make it easier in the future. In this case, we're going to call this one Eddie's. So I'm going to put the date in here. And save it as Eddie Reed. So now we have the file and it's saved. The very first thing that I would do would be to save this file again as mod 1. And the reason, we are human, we make mistakes. And if you're flashing the same file that you read and you try to flash it back and it's messed up, you get to start over again with a forward flash. So always save it as mod 1, mod 2, mod 3 as you're doing it. And that way it saves and make it easier for you to get back to it. All right, file is now read. And first thing we're going to talk about is that little FAST acronym, right? So fuel. The most important part of tuning a vehicle is injector data. Injector data is most important. So disclaimer here, if you use an injector that you don't have injector data, meaning you do not have any data for that injector, you do not want to try to tune this vehicle. It will not work correctly. Injector data is the most important part to tuning a vehicle. If it has stock injector data, such as this vehicle right here, and we didn't change injectors, it's easy. We can move on to our next thing and go from there. But if you have to change injector data, you make sure you have the right data. That's all I'm going to say on that. So injector data is part of our first thing we check on the fuel flow. So on fuel, there's other things we need to do. And in the Ford world, it's pretty straightforward and simple. To the left over here, we have the stoic air fuel ratio. Now you notice it's 1408. If you're from the 70s, you would know that fuel was actually 14.67 to 1 up until 2010, till we started adding ethanol to it, ethanol content. In this case, Ford and other manufacturers have realized that the ethanol content is now up to 15%. In this case, we're set on 10%, and the stoic fuel ratio is 1408. We have future lessons when we talk about that in the future, but for right now, you can see our 1408 tells us it's set up for 10% ethanol. If for some reason you are tuning a vehicle and you're using a different fuel, you're in South America or you're in Europe and your fuel doesn't have ethanol in it, then that would be 14.64 to 1. That just changes the lambda number, which we can talk about in future episodes as well. The lambda number means where it begins from the stoic air fuel ratio. Everything is targeted from that, which leads me to the next one, such as our power enrichment. Notice it says lambda, wide open throttle lambda on there. Wide open throttle lambda is based on the number. So give you an example. At wide open throttle, we're commanding 0.80. Now if you took 14.08 times 0.80, that would give you the number. So since we have a calculator here, I'm going to show you how this works. So I'm going to take the 14.08 and I'm going to multiply it times the 0.80. And physically see we're targeting 11.26 air fuel ratio. That is what that lambda number means, and that's the math of how to do it. If you didn't catch that, I can go through it again. So you can see we start off wide open throttle with 0.85 lambda, and we end up at 0.80. Obviously, the manufacturer tunes the car a little on the richer side for safety. If you want to tweak it, lean it out a little bit, you can. Just remember that the mathematics involved with it. If you have a flex fuel vehicle, then you would modify the one for the FFV. That's what FFV is when you see on the Ford file. That is flex fuel vehicle. Most people ask about that, weren't sure what it is, and that's what it is. Okay? So on the fuel side, the next one we have the oxygen sensors. In this case, it has 2 oxygen sensors. An interesting part about Fords from 2011 up, they have widebands. So a little explanation about a wideband. The narrowband sensor only measured 13 to 15 on the air fuel, whereas a wideband reads roughly from 9 to 20 on the air fuel. So the widebands also stay operational at wide open throttle. Get it? Wide band, wide open throttle as well. So when you're measuring your air fuel and commanding it, it's going to control it in what we call closed loop. If it had a narrowband sensor, when you went wide open throttle, it would go into open loop and it would rely on other sensors like the mass air. In this case, the widebands are actually controlling it in closed loop. So if we tell it the air fuel we want it to go to, those widebands will connect to it. The next thing we have on here is we have long-term and short-term fuel trims. A lot of people ask about that. And the simplest way to explain this is if we take a 5-gallon bucket and we drill a hole in the center of the bucket, as we start putting information in the top of that bucket and filling it up, the information that comes out the hole that we drilled would be short-term fuel trims. The information that comes out the top of the bucket would be long-term fuel trims. Obviously, short-term fuel trims are more time sensitive. They're not time late, whereas long terms are. And that will build up over time. So I recommend when you're tuning a car to disable your long-term fuel trims on the Fords and use strictly your short-term fuel trims to do that tuning. That'll allow you to get up-to-date information without any long-term information coming into play. Next thing we're doing when we're on the dyno and we're testing vehicle and tuning, we need to disable the catalyst efficiency for the test. If we're not, when you're wide open throttle and you hit cat over temp, what it'll do is it'll add fuel and will mess up your tuning process. So on the dyno, we would actually disable our catalyst protection. We would actually disable this right here so we do not have any extra fuel added to it. And very critical, when we're done, we will turn this back up. And I'll show you a little trick to help this as well. We would turn that back on so our cats stay nice and fresh and work correctly because they're very expensive. The next one on our cutoffs. So in this case, this car has a rev limiter at 8,300 RPM. And because of the flat plane crank, it's very smooth to 8,300 RPM. Your normal Coyote and your normal Fords aren't going to turn that hard. So if you need to move that limiter for some reason, say as you put a different intake on your car, you put different cams in your car that move the RPM higher, you can move the rev limiters up. So an interesting thing about this is we can make our own two-step. We can take our neutral cutoff and say 4,500, and at the neutral exit speed, we can make that 1 mile an hour. Now, if you have a larger tire, like a 29-inch tall tire in the back of this car, you could use 0.75 to 0.5. And the reason is, as soon as you release the clutch and there's one revolution of the wheel, as soon as it starts to make that one revolution, it will release a two-step, just like that, okay? So this car now would have a rev limiter at 4,500, and you can launch it. As soon as you left the clutch, go from there. We don't really have anything to do in the transient stuff. We don't have to mess with that. And if this was just a flex fuel vehicle, it would be enabled and we would see all the data here. In this case, it's not a flex fuel, but we're going to venture that later on. We're going to talk about flex fuel in a future episode. So the next thing we're talking about is airflow. And that's our little from our acronym there. So airflow wise, we got a couple things here. We control with speed density and or mass air. In Ford, we use both. We control it with a mass air and speed density. Now the mass air is a reactive sensor. It actually reacts to the airflow going across it and determines how much fuel is going to be added based on that airflow. It samples the airflow going in. Speed density, and the way that Ford has designed it, is more of a proactive sensor. It's predicting as well of where it's going to be on the next revolution of the crank. So you have reactive and proactive. I always think of my speed density as the one that's a follow-up, and my mass air is my full control. In this case, if we were tuning it, we would use our mass air versus frequency versus period right here. This is where we do our fuel controls, and I'm going to show you that in a little while, how we would modify that. If we were strictly doing a speed density vehicle, we would not have the mass air in there, and we would be using all these different map points. But you know what? Thanks to HP Tuners, we have our own speed density calculator that we can use for our different map points. Okay, so it makes it very simple for us to use to control our speed density, because it's not a real VE table as some people would think about. Also on the airflow, we speak of the throttle body. Throttle body in these vehicles are electronic throttle controlled. So there's no cable that runs between them. Whatever you step on the pedal is what the throttle is supposed to do. However, there are slight delays there with torque management and things like that. We have a maximum on a Ford you'll normally see between 83 to 90. In this case, the GT350 is set at 92 because the throttle body physically really can't go no more than 82 to 92 degrees. All right. So with that being said, if you look at a max throttle versus RPM, you see where it says 92 right there on the GT350. Your other Coyotes and earlier cars will max out roughly at 82 to 83. And that's not that it's not going to go any further. It's just the blade design itself, it can't go any further. IMRCs. So Fords have intermediate runner controls. Now people ask, why would they put blades in there in the intake? Well, it's really simple. The IMRCs restrict the size of the intake down to the size of basically a quarter. When they're driving around on part throttle and idle and everything else, it's about a quarter size of airflow going through the plate. And the reason that comes about is because that's port velocity. If you have more port velocity, then you have more torque. Those two go together. So torque equals port velocity and port velocity equals torque. If for some reason the plates were open at idle, you would have, with a large runner, you would have low port velocity, which would mean you'd have low torque. So the IMRC is designed to work at approximately a certain RPM. They're going to open, well, since it's 3,500 on this one, they would begin to open at that point, and you'd have all the torque and horsepower up. So you don't lose any transition at that point. You have torque and port velocity in the bottom, and you have it all the way to 8,300 with the cam change. All right, so in the IMRCs, we looked at that, and I explained how the torque control works on that as well. In this case, we can actually disable it if we actually took them out, which I don't recommend because we lose the torque and we lose the port velocity. So a lot of people will actually take and put an 18 intake on a Coyote, an earlier model Coyote. To give you an example, on 11 through 14, that intake is worth a good solid 8 to 10 horsepower, if not 12 horsepower across the band. If it's a 15 through 17, it's worth about 10. And of course, if it's an 18 up, it doesn't really need it because it already has it. People use a GT350 intake, which is very similar to it. It's a slight gain on the top, but on the bottom, it really doesn't gain anything. So your big gains are on your 11 through 14 when you put an 18 intake on, and your 15 through your 17. Now, I like to recommend that you keep the IMRCs on the intake to keep the port velocity up and the torque up. If it's a manual car, you can get away without it. If it's an automatic car, I still recommend keep those plates in there to keep the port velocity and the torque up. In the variable cam, tips and tricks here. One of the things here, you have to treat the cams just like an airflow model. So if you want to make more power at the top, then you would need to move the intake cam towards your exhaust cam to create the overlap. Overlap is what makes a cam choppy. So if you took in this camshaft and you moved it into the position it would be at 8,300 RPM and you tried to idle with it, it would be thumpy and thumpy and thumpy and jumping around because the camshaft has a lot of overlap. So the nice thing about TIVCT is when you start the run, you have very little overlap, and as you go through the RPM band, the cam goes together to create the overlap, which makes more power. So that's the idea behind the TIVCT. We have that control here, and I like to recommend moving that exhaust cam, and you can actually move a little further right here. Add 2 to 4 at a time. Make your pulls and look at your numbers and see where it goes up to, and when you're using the cams to control it. That's how you're going to move the power band around. It's a little tip and trick right there when you want to move it up a little bit. Okay? Let's talk about the mass air. In the mass airflow versus period, where we're going to make all our adjustments at, it's an actual linear curve. In other words, it should not have peaks and valleys and spikes and stuff in it. It should always be a smooth curve, as you can see right here. When you're adjusting it, if it starts to look that way, you need to go back and readjust it to make sure it's correct. This is where we're going to do our primary adjustments for our fueling if we're off on it. One of the reasons that Ford started using variable cam timing as well as electric throttle control is because in the 70s, we used to drive around in the 80s with a vacuum gauge trying to get our best vacuum for gas mileage, which nowadays is a critical thing with the mileage. It's a critical thing because of the gas prices we have. So we used to drive around with a vacuum gauge to try to keep it up there at 25 inches of vacuum to get our best mileage. Well, we didn't have variable cam and we didn't have electronic throttle control, so that was the best we could do. But we were wrong in what we were trying to do because we actually created a pumping loss in the motor. So what the engineers decided and figured out, we could actually retard the camshafts. We could actually use the throttle to keep just above vacuum, so there's very little vacuum to keep a pumping loss there, and we would make more power and would make efficient power all the time. So when you're cruising around, you'll notice that you have very little vacuum readings, and you have the cams on the retarded side to get your best economy. You can't do that with a cable, and you can't do that with a cam that's in one position. So that's why TIVCT and electronic throttle control work so well for economy. That's why this little GT350 can pull down 28 to 32 miles a gallon at 70 to 75 miles an hour because of the variable cam timing. The next one we're going to talk about is spark. Let's talk about spark advance. So when you talk about spark, people think of ignition spark and it just fires into the chamber. But there's a reason that we have to set the timing for it. We have to set the timing to hit at the right point to push the piston down. And the idea, if you actually put the spark at the time the piston was at top dead center, then it'd be too late because by the time it travels across the piston and pushes it down, the exhaust valve's opening and it's going out the exhaust. That's retarded timing. So we have to run the timing a little higher. So in this case, we're using an example. We'll say at idle, we're sitting at 23 to 24 degrees of initial timing. Well, we have to have that spark there to initially go across the chamber and push the piston down. So an easy way to make this work is to actually build a table based on load. These engines are based off load. So at idle, we're 10 to 20% load, and if wide open throttle, we'll say 100 to 105%. So as you can see, the timing will actually starts up here high, and at wide open throttle, the timing's here a little lower. And the reason is to keep it on the safer side. People say, well, how do I know where to start on my timing? If you ever have a question about where to start on timing, and you have access to MBT, okay, So that MBT is the basic, what the engineer thought was the perfect timing in the perfect world with the perfect scenario. We don't live in a perfect world. So we have to have a timing table that is not perfect. So we'll actually set our map point, our borderline is what we use for the real world. Our MBT is what the guideline is. So if you ever want to start square from nothing and you didn't know anything about it, you could take your MBT, take 6 to 8 degrees from that MBT, put it in your borderline table, and it gives you a good basis to start from. You might have noticed that this vehicle has a whole lot of spark tables. This thing has 27 spark tables. You're like, that's a lot of spark tables. Well, the reason is because of something Ford calls HDFX, High Degree Freedom Executive. And it was basically a process where they built timing tables and spark tables and torque tables to all work in conjunction to where any drivability situation you're in, it would be optimum. So if you take one spark table and one torque table, that's no matter where you drive, that's where it's going to be. Whereas with this, it can vary the map point to where you're driving, whether you're in economy mode, where you're wide open throttle, where you're in decel, whether you're idling, you can always get that best spark and best torque fuel table. So with those 27 map points, you also have 27 of your torque tables associated with it. But for right now, we're going to just talk about the spark. You notice we have map point 0 all the way down to our optimum power. On your 15 through 22s, the optimum power is not really used, but the other tables are. And when you actually drive the car, you'll actually see it will cycle through each one of these. And through our scanner, we actually get to see the map point of where it's at any given time. So you know where you're at when you're tuning the car. So if you're driving steady down the road and you feel a little burp or doesn't run right at a certain point, you can go back and look at your scanner and say, I'm in map point 7 driving down the road, and that's where my problem was. That's the point that you're going to go to and adjust. That's why we have so many map points. Okay, another little tip and trick here for Ford tuning. If you want to set the timing so it won't go any further, let's say you got a car, you don't want any more than say 24 degrees of timing. You don't want the computer to add it because the computer can't add the timing. The quickest way to do it would go right over here to your cylinder pressure limit. This is your final determining factor for your fuel spark associated. So at wide open throttle, you can see this right here. At wide open throttle, we're limiting to 30 degrees. Now this computer will not add more than 30.3 degrees or 30.5 at 8,000 RPM, no matter what you put in any other table. That is the final determining factor, is your CPL data. So when you're clipping it off, let's say you got a car that you want to clip it off right now and you want it 18 degrees, you can go in here and put 18 degrees here and it will not go more than 18 degrees. So that's a little tip if you're tuning a car, what you can work with and make it safe to start out with. So no matter what you set in your other map points, that will be your limiting factor. Why would you do that? Let's say that the vehicle is running nitrous or a turbo or blower application and you want to keep it no more than 15 or 16 degrees, then stay at 15 to 16 degrees by clipping it off right here. So the next thing in spark when we talk about, we have a couple of little things here. We have an octane adjustment, and this is based on the octane of the fuel. If you got good octane fuel in your area and you're running good 93 or good 91 octane, you could take this out and zero it out from -3, put it at 0 so it doesn't affect your timing curve. You could do that. But if you're running an area where you don't have real good fuel, keep your octane adjustment there as a safety factor. The next one you have is your IATs, or in this case, it's a manifold charge temperature. So you're going to see this in the later model vehicles. It have inlet air temperature and manifold charge temp. It's important that they call that because the manifold charge temp is now in the manifold, so it's the charge temperature that's in the manifold, not necessarily the inlet air temperature. But you'll see them coincided to, you'll see them together in your tuning software. And you'll notice at that point, so at 150 degrees of inlet air or manifold charge temp, it would actually say it'd retard -50 degrees. It's not going to retard -50 degrees because there's an actual multiplier that goes with it. In this case, if it was 0.1 and we did that, so we're looking at 5 degrees of timing is all it would retard at 150 degrees of downstream temperature. This is important if you're using a metal cold air kit. I can't stress this enough. If you're using aluminum or a metal cold air kit instead of a fiberglass or composite, that retains a lot of heat. So as you're sitting at idle at the stoplight and you're 100 degrees outside and your inlet air temperatures under hood are 150, 160 degrees, it's going to start pulling timing. So if it's pulling timing and you try to run the car until the airflow goes off to cool it enough, it's going to be less timing than optimum. So I recommend modifying your inlet air temperature or your manifold charge temperature accordingly, depending on what kind of intake tube you're actually running. We mentioned earlier about the knock sensors, that it can add timing. And you'll see in the Max Advance here, the system will actually add up at this point a wide open throttle of 2.5 degrees. So if it's looking at it, doesn't see knock because the knock sensors are very aggressive. If it doesn't see any knock, it's going to add the timing. If it sees knock, it's going to pull timing away. So very critical that you understand that this computer is very smart, that it will add and it will subtract timing depending on whether it sees or hears knock. Let's talk about torque management. Torque management can be modified and the car will feel better right off the bat. If you're driving the car and you modify the torque management, you're going to notice a substantial difference in driving. Okay? That doesn't mean it's got more power. However, just torque management in a lot of vehicles can knock off a quarter to a half a second and a quarter mile time just from modifying the torque management. Now, why is torque management there? Torque management is there because we have to have things have a warranty. We have things to live. We want the transmission to live. We want the clutch to live. And that's where torque management come in. So to modify the torque management to make what you want the car to go to, you modify it from here. So a couple things we can do. Number one, let's talk about the actual driver demand and pedal map stuff. That's probably the most important part to driving a car. If you've ever driven a Mustang with a manual and automatic and you have normal mode and sport mode, you notice the throttle feels much different in sport mode. And that's because they basically take the pedal map from normal, which you'll notice here, pedal map is 50-50, 80-80, 90-90. Well, when we put in sport mode, now if you look at 38% pedal, we've got 50% throttle. So we're enhancing the throttle by using the sport mode, which makes it feel peppier, which means that it's stronger in relation to the pedal feel. All right, that's pedal map, as we call it, modifying the pedal map. Now, you can go one step further. Let's say that you have your 15-year-old driving a car and you put in mud setter. So it's the opposite way. So at 70% pedal, you're only getting 40% throttle. So there's other ways we can do that. If you're climbing with a Mustang or a truck and you've made a four-wheel drive, you can do the same thing. You can reduce that pedal map down so it's more controllable. Those of us in the performance world, I want the pedal to be on like Donkey Kong. So that's what I want. All right. That's torque management, and that's where we'd modify it at right there. All right. That's one of them. You also have one in the transmission. Give you an example. So we have something called clutch protection. I alluded to that at the beginning. So in order for the clutch to live a longer, happier life, for a lot of people these days who've never driven a manual transmission and they buy one, you try to drive the car in order for the clutch to live a happy life, Ford puts in torque management on the clutch. We can modify that. We can zero out the RPM saying, so when you dump the clutch, it comes right off. All right. Interesting story behind that. In 2011, when we first started tuning these cars, ran into a problem. I'm at the track with slicks on the car and I'm launching the car full throttle and the car would nose over every time. And I'm like, traction control's off and it still closes the throttle on me. What's going on? Well, eventually we realized that the software didn't have it in it and it came out later. We had clutch protection. Once we turned off the clutch protection, I was launching the car and carrying the front wheels. Amazing how much that actually works. One of the other things in torque management that we will actually see is the actual torque of the engine in relation to what the output is. All right. So if you ever look up your actual maximum torque versus gear, you'll notice that they're set, 396 to 400, which on a stock Mustang, you're making around 350 to 360 foot-pounds of torque. If you exceed that, let's say you're exceeding at 450 foot-pounds of torque, that can come in and close the throttle on you. So you may need to modify that right there for that. Just remember, the more torque you make, the more torque you put to the wheels, that you need to make sure it matches on your screen. So if you put nitrous on a car and you're up to 550 foot-pounds of torque and it's clipping at 380 foot-pounds of torque, it's going to shut your throttle on you, okay? Just remember that. We go into the transmission one, a little bit of transmission stuff here. So I brought on an automatic transmission file and let's see. Here we go, automatic transmission file right here. We'll bring it open. Transmission. Torque management in the transmission. A couple things here. You've got limits. We talked a little bit before about the torque limits. In torque management, there is an abuse mode. If you disable abuse mode and you're out there and you get it stuck in the sand, you're trying to rock back and forth, it can actually burn up the transmission. When the abuse mode is enabled, it will not allow you to do that, just so you know. So if you disable it, it's on you and you're responsible for the transmission at that point. On the upshift side of it, torque reduction comes into play. So with the foot-pounds of torque here, noticing that on the next side we have 345 foot-pounds of torque on our axis, right there. And you notice on the turbine speed, we're over here of 5,000 RPM, or engine speed of 5,000 RPM. We're at 551 foot-pounds of torque. In order to make the transmission shift firmer and crisper, we can actually increase that number. One of the things you can do to these is just add 100, 150 to each one of these from 315 up, and that'll actually make it a little bit crisper on you. And that's the idea behind the torque management. Just reducing that makes the transmission shift firmer, makes you get quicker without doing anything to the engine for power. Downshift wise, if you go to sport mode, you notice the vehicle downshifts more abruptly because of the torque management is reduced. If you don't like it, you can go in and modify that, put it back to stock in your sport mode. Or if you want it to do that more, you can enhance that the same way that you just did on the upshift. Bring that number up for more actually horsepower, torque allowed to go through the transmission. On the transmission itself, we're setting max in pressure. So in this case, this vehicle is already modified, this automatic one I'm showing you now, and I have the pressure up from 150 to 215 PSI for the transmission pressure. So people ask, how do I make my transmission shift quicker or firmer? Well, to make it firmer, you got to make it quicker. And to make it quicker, you need to have more pressure. And then you would modify your on and off of your slopes, which we'll talk about in future. We're going to talk about transmission in the future. So, but you would modify those and your basic pressures to make the transmission shift firmer. All right. So if you want the transmission to bark the tires on the shifts, you're going to modify your actual pressures, and you'll modify the actual torque management for it as well. Those two major things come into play. All right. On-shift scheduling is not really torque management, but one of the things on an earlier model car, you have the same thing. Now, if you've ever seen, or if you've never seen an 11 through 14 transmission function, it shifts off of engine RPM. In 2015, Ford started using output shaft speed as the controller. So you'll notice that the output shaft speed for each gear shift is here, and it's not engine RPM. Same thing, if you're shifting at 5,500 and you want it shifted 6,000, you just do the percentage of that, and you do the percentage of your OSS, and you're right on its target, okay? So output shaft speed is used on your later models. If this was a 2018 up automatic car, which is not, this is a manual car, it still uses output shaft speed, but on part throttle driving, it will go first to third, then third to fifth, and then fifth to seventh. It has something called skip shift. And the reason is because you really don't need it going 1 to 2, 2 to 3, 3 to 4 all the time when you're driving on as a part throttle basis. So Ford created the skip shift programming in the automatic. Now, a lot of people, when they're driving it, feel like transmission feels slushy. It doesn't know where it feels like it's shifting at. But when they go to sport mode, it's crisp, right? Boom, boom, boom. First, second, third, third to fourth. You can modify and put your sport mode in your normal mode. But what you do, your gas mileage is going to go down, just heads up, and it's going to be that way all the time. So I recommend, if you're going to modify your stuff, use your sport mode for your power and your performance driving, and use your normal driving, your base as we would call it, modify that a little bit just to what you want it to feel like, okay? And you can do that by simply as going into the base. In this case, we don't have the skip shift, but if we were, we could actually move these numbers up above it. Okay, we were talking about an 18 up with the A10 transmission, and we were talking about the fact of the skip shift. So I want to show you what this looks like. Again, it's using output shaft speed. But if you notice right here on this, it's actually moving up through the power band, all right? If you notice on the screen, if you're part throttle driving, first or second will come in, no problem if you're just barely moving. But if you're in the throttle a little more, it's going to wait till 600 RPM in the output shaft speed, whereas the control for the first to third is at 300. So it's going to shift first to third, then it'll go third to fifth, and then move up from there based on the part throttle stuff. So most people don't like that. If you want to change it, you can change it from here. You could take this right here, say, boom, copy that right in as 10,000, like so. And will let me. There we go. So you notice I went to 10,000. So skip shift will not happen from first, when it goes from first to second, it'll go first to second, then second to third. If you want to see what it looks like, you just look over at your sport mode because it's already done for you. You can see that the skip shift is not active by doing that. So look at your compare between the sport and the base, and you can see the difference. I recommend just the part throttle stuff moving a little bit, but after that, I would let it do the skip shift and it'll get better gas mileage and it won't abruptly jerk your head around, okay? All right, so we talked earlier about HDFX. We talked about the spark and the multiple map points, and we talked about the torque model. So these engines and the drivability stuff is all done by torque request. So, and all these map points equate to it. So if you're idling in map point 0, this is the torque it's requesting. If you're driving along there and now you're in number 7, map point 7, the engine torque requesting is that. So the engine torque has a graph slated like this. The top axis is 500 through 7,500. That's your engine RPM. The axis on the left is actually engine load. And if you notice, the center numbers are your torque request, okay? So at wide open throttle at 4750, we're at 480 foot-pounds of torque roughly that's requesting. Now, if you notice there's a little inverse table. The inverse is just the inverse of that, meaning load, all right? So now we have that same torque number on the left for the axis, all right? And the RPM still at the top, but now we have the load set up in there. So if it's requesting at 400, we said 480, right? So at that point in time, that's 1.02 load, which Coyotes will make 110% load. So as you can tell, it's just an inverse torque setting. Now, if you put a supercharger on the car, you'll notice we have 590 foot-pounds of torque. You notice that load would be 1.36. So Ford kind of predicted that, hey, they might put in a supercharger on this car, and that load's correct. This needs to be modified if you are going to do a certain calibration for a big PD blower, meaning a root style blower, positive displacement blower. This would all have to be modified accordingly, all right? My recommendation to that is use a Whipple or a Roush calibration to begin with if you're doing a root style blower. So people ask, what about the shift points in the RPMs? Well, it's based on OSS. So if you know the shift point that you want to shift the transmission at, you want transmission to shift at, say, 7,200 RPM, if you take that and you know your gear ratio you're in, which you can actually get from your transmission right here, I'll show you, transmission general. Okay. Gear ratios by gear, there's your gear ratios by year. Everybody see that? So if you know that fourth gear has a 3.79 ratio and you have 7,200 for a shift point, if you take that number and divide it by 3.79, then you actually get the actual ratio based in that. So if we do the math, all right. So if you do the math, and I just kind of did a quick one on there. So at 7,200 minus that percentage would be a 5,000 RPM output shaft speed. So you would go to the output shaft speed sensor and you would modify it accordingly. So the two important things to remember when you're trying to calculate for where we want to shift at. Being that we're using the output shaft speed for the control, we need to know the ratio of the transmission in that gear. We can actually go right to the transmission. We can actually go up here to the general, and we can actually, we actually pick the gear ratios right there. So if you notice, there's first, second, third, fourth, fifth, sixth gear ratio from that. If we take the engine RPM and we actually divide it by that gear ratio, that gives us the RPM from that gear ratio. And so we know what output shaft speed we need to modify it at. In that case, if we wanted our, in case fourth gear, 3.79, to shift at 7,200, we would need to make that 5,500 because we would do this. So we take this tool, calculator, we want 7,200 first shift point, all right? And you divide us by 3.79, which gives us basically at 1899 for reduction. So if you take 7,200 minus that number, or just do this. So basically 5,300 would be the output shaft speed we would need to shift at. Okay? So we would come in here next, and we would go here on our third or fourth right here, and we move this up to say 5,200 at that point. It's pretty straightforward and simple. Okay, the next one we're going to talk about is your fan controls. The internal combustion engine would like to operate at 180 degrees for efficient power. Well, Ford targets 212 on this vehicle. We want to bring it a little bit cooler because we want the fans on a little cooler for more power. So we're going to target 200. The way to do that, here we come up in this and change this to 200 degrees. And we want to look at this, we want to change our axis as well. And the way we do that is we'll take this one at 5 degrees below it, 200 for our number, keeping our same flow, and then it's a smooth transition to come in for the fans. All right, so that's what it'll look like right there. It comes in right at 40 for 200 and 100% duty cycle on the 212 up. Now the other thing that's in here is your actual disable time. At wide open throttle, it'll stay off for 10 seconds at wide open throttle. Your fan will stay off. If you have a 12 or 13 second car and you want all that little extra you can get, you can make that 13 seconds or 15 seconds just by changing that right there. So the fan will not come on for 15 seconds at wide open throttle, which means less parasitic draw on the alternator, which means more power, maybe at thousandths, maybe 2,000ths, but it will go faster at that point. That's how you would change the fan control. So there's two other things we want to talk about. One of them is cam reset and why we use the cam reset and how to use the cam reset. So cam reset stands for keep alive memory. All right, keep alive memory is there for your adaptives as well as certain memory functions in the computer, such as your timing for your crank relearn. All right. So in order to modify and take out your cam reset, I'm going to show you the basic function here. All right. So opening the scanner, we just connected a vehicle by connecting to the vehicle here. Make sure the ignition switch is on. We are now connected to the car, as you can tell by the top. So in our vehicle controls and special functions, we have several things here. In the very first one, you see crank relearn and cam reset. In order to do the crank relearn, you actually have to do the cam reset, the keep alive memory reset. So I'm just going to show you the function here. You would actually hit the cam reset. If make sure engine is not running, the key is in the on position, you hit OK. At that point in time, it will clear the keep alive memory. All right. In this case, I'm just going to leave it alone. I can do that to Eddie's car. Okay. Eddie, I did not touch your keep alive memory. Functional cancel by user. Okay. So the keep alive memory, like I said, is used for the crank relearn. Crank relearn procedure is extremely simple on the Ford. You hit the crank relearn. It tells you engine has to be above 80 degrees Celsius, parking brake applied, transmission to park or neutral. And basically when you click it, when it's at that temperature, you just rev it to the preset RPM. It says 4,500 RPM. You rev it up to that. As soon as it hits it, you let off of it. It comes back down. Crank relearn is successful. And the next question is people say, hey, how do I change my speedometer setting if I go to a larger tire or change the gear ratio in the vehicle? It's extremely simple. Once it's connected through the scanner, select up speedometer, speedometer adjustment, gear ratio in this vehicle, a 3.73. We would type in 3.73 and we would hit OK. And then would ask the revs per mile. And the revs per mile would be 788. So we'd say 788 at that point in time and we would hit OK. Speedometer adjustment was successful. It's that simple to change the calibration. It doesn't require any credits. It's done through the scanner. Thanks to the team at HP Tuners. Works like a champ. So many people have asked about turning off the PATs in a Ford. We'll take a 2005 Mustang as an example. We're going to open up the file. We'll go to our system. Right here to our PAT switch. We'll do a disable. We'll do the PATs alternate disable as well. Save the file. Write it to the car. And now the PATs is disabled. If you're trying to disable the PATs on a Coyote, we do not allow that in our software at the present moment. Thank you for watching our Ford tuning tips and tricks. Please comment below on anything you'd like to see in the future. We are looking to do maybe more videos on these to get more information out there. I myself know there's a ton of information to get out there, so the more we get out there, the better it's useful for you to use. I'm Tony Gonyon from HP Tuners, Ford Gas Sales Manager for North America. Thank you for watching our video. Look forward to doing more for you.